Hi, this video is to talk about the first order exponential smoothing model. This is also a short-term forecasting model, and in this model we're going to use a weighted average method that includes the previous observation and previous forecast. This previous observation, previous forecast is used because we compute the error from the previous forecast with what happened, and then we're going to give a coefficient, use a coefficient to weight this error from the previous forecast. This is the most used of all forecasting techniques and is an integral part of computerized forecasting, and is well accepted for the following reason. The exponential models are surprisingly accurate, and formulating an exponential model is relatively easy. I'm going to show you how in Excel the user can understand how the model works. Little computation is required. Computer storage requirements are small, so we can do it in any laptop. And tests for accuracy are easy to compute. Let's take a look at the formula. This is the formula for the model. So what we have here is the forecast for the next month, the t plus 1, so period is next month, is equal to the sales from this month plus the error from our previous forecast and the sales in the previous month or this month. So we had a forecast and we forecast a given amount. What happened like this variable is talking about that. So the difference is how much error we have. And then we're going to multiply that for a coefficient that we're going to determine. And then this is going to be something to add to the actual sales in order to forecast the future. So here's the terms. Let's take a look at Excel, how it works. So I'm going to use the diving watch example again. So these are the months and the demand like we had before. And now let's start using an alpha, which is our constant, a smooth constant of equal to 0, alpha equal to 0. Okay. In this case, to perform this computation, we need a starting value. So let's use a starting value of 12 units as demand. So we need a starting value here as a first forecast. Okay, so my forecast for February, which is the next month, is going to be equal to my previous demand, my previous forecast plus a coefficient. In this case, the coefficient is 0. So it's 0 multiplied by the difference between my demand and my forecast. So this is how it is. Okay, so it's 12. Now let's forecast for March. Forecast for March is going to be equal to my previous forecast plus my alpha, which is 0, multiplied by the difference between my demand and my forecast. You're going to see that it's 12 again because this 0 multiplied by any number is going to be 0. So I add my previous forecast to 0 and it's always the same number. Okay, so I can simply copy this formula. And if I want to predict October, then it's going to be 12.2 because my previous forecast was 12. And then I add a constant, which is 0, a coefficient, which is 0 is my alpha, multiplied by the difference between my previous demand and my previous forecast. So I make the difference, it's 12 again. Now let's change alpha. Let's make an alpha equal to 0.2. We use values between 0 and 1. So how much weight we want to give to the error in computing the previous forecast. So again, we need a starting value. The starting value is 12. Let's use 12. And then now we can do my previous forecast plus how much is the coefficient now? Is 0.2 multiplied by the difference between my demand and my previous forecast. So that's a little bit different than this 12. Now let's do it again one more time. Now for March, my forecast will be equal to my previous forecast plus my coefficient, in this case 0.2, multiplied by the difference, I open parentheses, between my previous demand and my previous forecast. So you see that this part of the formula is the error between the demand and forecast, and I'm given a weight for this error. Okay, so this is what it is, and then I simply can copy all these formulas, and if I want to check, I go to the last one, click here, and make sure that my N14 is my previous forecast, and then I have 0.2 multiplied by this difference, so it's correct. If I want to reduce the decimal places, I go here and reduce the decimal places. And if I want to, let's now use 0.4, or let's use 0.4. So 0.4 again, my starting value is 12. Now I have my previous demand plus 0.4 multiplied by the difference between my demand and my forecast, and that's it. Okay, let's do one more time and then I can copy the formula. So my demand for March is equal to my forecast for March plus 0.4, that's my coefficient, multiplied by the difference between my previous demand and forecast, and that's it. And then I can copy this formula to all other numbers, and then I have, and I can reduce the decimal places, and that's it, right?